Sounds like a good time.
But I don't have to pay.
Well, good.
And I can drive my dad's truck.
I love your dad's truck. Saw you pull it.
Okay. So, last section, the parade. I figured you guys wanted to do a Desmos thing tomorrow instead of a quiz, so that's what we're doing. Unless you want to do a quiz.
You know, I was just about to say I love you, but that's like inappropriate, so I'm not going to say that. But like the strongest feeling that a student can feel towards a teacher. That's what. Thank you.
Welcome.
In an appropriate
Yes.
In an appropriate. Okay. Yeah, because then Wednesday we're gonna review, and then Thursday, Friday are the tests, and then next week we're gonna do.
Hey, I like the project.
Yeah. Brain's scared for the project, people.
It was.
Okay.
Oh,
Do they
So-
train? Do they train teachers how to defer questions? Like I feel like you guys would do good at like sitting next to the teachers like, go find out.
Yep. Moving on. So we have 3 different ways we can write the equation of a parabola. What is one of those 3 ways?
This is standard journal and intercept.
Yep. So what is general form?
Y equals ax plus or ax squared plus bx.
Good. Okay, so that's general form. So basically today we're writing the equations of parabolas. So we can write it in general form, vertex form, and intercept form. And it all depends on like what information is given to us. So general form is like the worst way to write the equation of a parabola. Okay, because the A, B, and C value don't really represent anything. Right? So to write the equation of this, we have to be given 3 points. So if you're given 3 random points, you don't know if they're the vertex, x-intercepts, y-intercepts. You can use general form to find the equation. What does standard form look like?
Is the intercept the one where it's a times x minus q?
Mhm.
I can't do it.
Yeah, intercept form is like x minus p, then x minus q, so you have 2 intercepts.
Standard form is y equals a parentheses x minus h squared plus k.
Right. So standard form and intercept form are easy to write the equation of them.
Not equals time.
Yes. Okay. So basically, if you're in standard form, you need to be given the vertex. So if you know the vertex, then that replaces the h value and the k value, because hk is the vertex. But then you need an additional point to find the value of a. So a could change, and we don't like, a point won't determine the a value. So you have to use the point to actually solve for it. Same thing with intercept form. You need to be given the x-intercepts. Once you know the x-intercepts, then that replaces the p and the q value, but you still need to know what the a value is. So we need an additional point as well. So standard form and intercept form won't be too bad. General form is like a monster, so brace yourselves. We're going to do one of each. That's too bad. Okay, so write a quadratic function for the parabola with vertex -2, 3, and a point -4, -1. So if we're given the vertex, should we write it in general form, in standard form, or in intercept form?
Intercept. No. Standard.
We're going to write it in standard form
Yeah.
because we're given the vertex. So since the vertex is -2, 3, Negative 2 and 3 will replace which letters in standard form? Yeah, so typically the vertex is h comma k. So now we know h is negative 2, the k value is 3. So I can write that in. I have y equals a. X minus negative 2 is plus 2. And then plus 3. Right, so we just substitute in the vertex into my standard form. But I still need to figure out what is the a value. And that a value is going to be some number, I just don't know what it is. So the vertex is already used. We're going to use negative 4, negative 1 to solve for the a value. So what does negative 4, negative 1 represent? Okay, so this is a point. And how do we typically write point? X comma y. So basically the x value is negative 4, the y value is negative 1. So we're going to substitute those in for y and x. So negative 1 equals a. Negative 4 plus 2 squared plus 3. So now I can basically solve this lovely equation for the a value. So what do you want to do first to solve?
Add negative 4 and 2 together.
Okay, which is, and then what?
And you can square it. So that'd just be 4.
Mhm.
So 4a plus 3. And you subtract 3 from both sides. 4 divided by 4, you get negative 1.
Okay. So basically, I know the a value, the h value, and the k value, so I can write my parabola in standard form now. So now we have y equals negative 1 for the a value, and we still have the x plus 2 squared plus 3. So there is the equation of my parabola with that information. Nice. So that's standard form. Not too shabby, you just have to know where you're plugging things into and what you're trying to do here. Otherwise, the math is really simple. Okay, here's our next one. So I write a quadratic function for the parabola. We have x-intercepts of negative 4 and 0, and we have a point, negative 3, negative 4.5. So are we going to want to write this in general form, standard form, or intercept form?
You would do general.
Intercept form because we are given the x-intercepts.
Oh, and a point, yeah, sorry. I was thinking.
So the x-intercepts negative 4 and 0. What does this represent in my intercept form equation? So I can say Q to 4 is P, 0 is Q. You can have it flipped around, it doesn't matter which one you identify as. So I'm just going to substitute that in. So then it's minus negative 4, which is basically plus 4. And then x minus 0 for the Q. And just like vertex form, I need to figure out what the a value is. And we're going to do that by using the additional point. Gotcha. So negative 3, negative 4.5, this is your x comma y value. So we're going to plug that in. So
Negative 4.5 equals a parentheses negative 3 plus 4 parentheses 3 minus 0.
minus 0 isn't doing anything. I don't technically need to write it, but I did. And then order of operations to solve.
Parentheses.
Yeah. So negative 3 plus 4 is.
1.
And negative 3 minus 0. Okay, 1 times -3 is -3. Move on, divide. Oh, that like 1.5. Okay, so then we have the A value, so going back up to this guy. Rewriting the same thing, it's just 1.5 is in for A now. And you can leave it as x minus 0 if you just want to write x, you can. Either way, it's still the equation of the parabola. So we're good. Nice. So same thing, not too bad, like the math part is easy. Word of operations is just knowing where you're substituting things in the goal, or in the parabola. So one more. We have another thing after this.
Wait, can you go just a little bit?
General.
Yeah, I don't know why. Yeah, so we want to write in general form, which is that y equals ax squared plus bx plus c. So we're given 3 points. So none of these points represent a, b, and c. They just represent the x value and the y value. So bear with me, this is a hot mess. Yes. So starting with the first point, -2, 30. Plugging it into general form, 30 is the y value. And -2 is the x value. So I have a -2 squared plus b times -2 plus c. And I'm just going to simplify this out a little bit before I move on to the next point. So 30 is still on the left side. But I can rewrite -2 squared, which is 4a. And then instead of b times -2, I'm just going to write it as -2b. And then plus c. So that's 1 point down. Have it solved for a, b, or c. Like I can't do anything with that equation. Not helpful. So moving on to the next point, 1.6. So same thing, we're replacing 6 for the y value and the 1 for the x value. So a times 1 squared plus b times 1 plus c. And same thing, I just want to rewrite this so it doesn't look so messy. 1 squared is 1. So I have a plus b plus c. Same thing, I can't do anything to solve this or simplify it anymore. And moving on to the last point, 4.36. So still replacing the a value for the y value and x value. So 4 squared is 4 squared, 16. Instead of b times 4, we write 4b plus c. Okay, so this is what I need to use to solve for a, b, and c. And we've solved problems like this before. Does anybody remember how to solve something like this?
Yeah.
So I think you're thinking of like determinants.
Kind of.
Is that right? Like circling the diagonals?
Yeah.
Okay.
You do that?
The determinant isn't gonna give us the solution. You have to do like Kramer's rule of determinants.
Lead the way.
Did you want to do Kramer's rule?
No.
There's different ways of solving.
Just do it how you would do it because it's probably the easiest.
Okay, so this is a system of equations. So we can solve it by like substitution method. We have elimination method. We do have Kramer's rule.
Let's just do elimination.
We have like inverse method.
What would you use?
I would do elimination method.
Okay, we have secret. Let's get going.
Okay. So elimination method, we need to eliminate a specific variable. Do you eliminate the A value, the B value, or C value?
The C value, it looks like the E is true.
I have no preference. So is that what everybody agrees on?
Yeah.
Okay, so we're going to eliminate the C's. So are we working with the first and second equation, second and third, or first and third?
First and third.
Okay.
Why not use
You can use any combination, so it doesn't matter. Greg said first and third, so that's what we're doing. So to eliminate the C's, I need them to be opposite signs. So I'm just going to take the first equation and multiply by -1. So then we have -30 equals -4a, then plus 2b minus c. Third equation we're just going to leave as is. The elimination method, we're going to add these vertically. So -30 plus 36 is
66. Oh, yeah. I get you now. I thought it was.
and then -4 plus 16 is
12.
12. 2b plus 4b. And then my c is eliminate, which is what we wanted to have happen. So there's one equation. So let's eliminate the c's again. So can't use first and third, we can do second and third, or first and second.
First and second.
Okay. So first and second. I'm just gonna keep the first equation by -1, so -30, -4a plus 2b minus c, and then just rewriting the second one underneath it. Okay, so then adding straight up and down, -30 plus 6 is -4a plus a. -3a, and 2b plus b is 3b. And then my c's cancel, which is what I want to have happen. Okay, so eliminated one variable, which is good. So now I have two equations left over, and I need to eliminate the a's or the b's now.
It's only these.
Okay. So what are we going to multiply into what equation?
2.
So the second one, and I should do -2. So that means
another one up close?
positive 60 and a -60. So the first equation I'm leaving as 6 equals 12a plus 6b. The other one, when I distribute -2, what do we get?
48. 6A. -6.
And same thing, we're going to add vertically. So 6 plus 48 is, and then 12 plus 6 is, and then my b's eliminate just like I want them to. So we almost have one variable solved for. I can divide by 18. So a is, this is 3. So then, just like always, once you have one variable, you just substitute it back in to find the b and the c value. So I go up to like the 6 equals 12a plus 6b, and the -24 equals -3a plus 3b.
6 equals
Okay. So that guy, we're going to substitute. So we have 6 equals 12 times 3 plus 6b.
36.
-30. So then I have A and B. So then I could go up to one of these original three. I would probably do the second one, because that looks like the easiest one to substitute A and B into. So we have 6 equals A value of 3 plus -5 plus C.
Are you gonna make us do general on our test?
I don't know. So then 3 plus -5 is 2 plus C. And then add 2. Okay, so we found A, B, and C, but we were trying to write the equation of the parabola, so now just substitute it back into general form. And we have the equation. So y equals 3x squared now. Minus 5x plus 8. Woo! See, wasn't that so fun? It all comes full circle. Everything that we learn comes back to haunt us. Yep.
It's always the thing.
Okay. You ready for one more thing?
Let's
Woo! You're welcome. Okay. So we need to talk about a best fitting quadratic model because basically we've been writing quadratic models this whole time. But this works specifically with data. So if you're given data, we can approximate the quadratic equation. So just like with any real life data, so we did linear regression. The points could be in some form of a line, they don't have to be exactly straight, right? We could approximate the line relationship. Same thing with the parabola, I could have data that's looking like a U, they don't have to form a perfect U, but we could approximate the parabola that would intersect through the majority of those points. So that is our goal. So instead of giving 3 points that I know is part of the quadratic equation or the vertex or intercepts, we can be given a data of 6 points, and we want to just best fit the 6 points with my quadratic model. So most of the times we're going to write it in general form just because that's what is best, I guess, or easiest. And we should talk about this correlation coefficient, which we have talked about before. It's the R value. But basically this, what is it? I'm going to say identifies the strength of the model to the data. So if you remember, the R value is always a value between -1 and 1. So the closer it is to -1 or +1, the stronger the model is to the data. The closer it is to 0, the weaker the relationship is, basically. So quadratic model, if it's 0, probably does not fit the data at all. But if it's 1, then we know we did a pretty good job. Or close to 1, at least. So we're going to be given some data. It's basically a story problem, but we can't really find models very well. We could approximate the parabolic model or whatever. But we're going to use Desmos. And I'm going to use Desmos because that's easier than using your graphing calculator. Graphing calculator for regression is not user-friendly, in my opinion. Yeah. So if you have your Chromebook, that would be fantastic. Yeah. Do we have all of that stuff in our best fitting quadratic model written down?
Yep.
So that way I can scroll up to the data.
Yeah.
Very good, Gracie. Yeah, so just type in desmos.com and then there should be like some button that says like start graphing or I don't know.
Like graphing calculator.
Yeah. Okay. So basically what you need to write down is this lovely little table here. So if you're in the correct Desmos case and you click graphing calculator, there should be like a graph on the right side of your screen and like this column thing on the left that you can like type into. Hopefully.
I got this.
Yes.
But do I just write x equals 8? Or x?
Step one. So we want to press the plus sign in the top left corner of your screen and go to table. So then you should have like an XY table in line 1. So then the X values are 8, 10, 12, 14. Y values are those. And you can type those in. And then after you get the table in, I'll say what you
On.
Yeah. So we want these all in one line. Yeah. So basically, Desmos is awesome. What are we doing? Press the plus sign and go to table, and then get the data. And
Just like that.
table. Okay. So the next thing, once you have the data in, so you could like adjust your like window screen. So right now, Desmos has graphed these 4 points, but you can't see them because your window is like too small. So there's like a wrench, right, in the right corner. So then you can like eliminate what the X value is and Y value. So there's like this scale. So there's like some number, and they say like less than or equal to X, less than or equal to some number. Same thing, a number less than or equal to Y, less than or equal to a number. So you should adjust those at least so that way your smaller number is less than 8. Larger number is greater than 14 because that's what you plotted. Same thing with the Y value, your smaller number has to be smaller than 1180. Larger number should be bigger than 1675. Just so that way we can see the points on our graph. Let's change the little raise for your X values, so around those.
So instead of the -10, do like
Do like 5.
5. Got it. What did you do? Your points?
For my points, I did change my points. Well, I put 715
Yes.
and 1179 and 1676.
So why don't we see, so their points is 30, so that's, okay, that looks fine. Yeah. Okay, what point did you get?
What?
What point did you get?
That's 715, 1179, and 1676.
It really doesn't matter what the numbers are, just as long as they're around your x-axis. X values in your table and the y values in your table.
Yeah.
Yep. Just as long as you can see all 4 points. Type in whatever numbers. Okay, so now that we can see the numbers, we can see that it's going to be a parabola opening down for a value stuff and it'll be negative, which is nice. But for the Desmos to actually generate the model that we want, we need to type a specific like code. So we're going to write in general form. So this isn't what we're going to write yet, but we want it to generate this equation. But our table, our x value in the table and the y value, it was represented as x1, y1. So we need this to be y1, x1, x1, right there. And then the equal sign is not the code to create a regression model. We need this lovely squiggly. So you can input this equation into like the second line on the left column. When you do that, it'll generate a value, b value, c value. As long as you type it in all correctly.
I just need to type that.
Yep.
Exactly. So we have to read it add or what?
No, you just like right underneath the
Oh,
How do you get the Y1?
You hit
You
the
shift
control. Shift.
and the squiggly is right underneath the escape button.
How do you get back?
It's like arrows right.
I don't know what I did for it.
And how do I do this squiggly button? Oh, right there.
That doesn't make sense.
So shift. Einstein.
How do you get the, and then how do you get the
Yeah,
square again?
these are ones, not commas.
Hey, how do you get the 2x?
Shift 6.
Reading this.
Top left.
So we'll see if it doesn't generate. Nope. They generate the ABC value. Is this the oh.
Oh,
Squiggly. Shift 6.
Yep.
So why did it take it back over there?
Because you want that 0 out.
This is
It's faster than the graphing. Why is yours
let's see. Bam! I got it!
So you listen like what did you do? Can you do that again? What did it say?
Oh, there's a space.
Oh, there we go.
But no.
That's excellent.
Like
That
this?
was fine. Yeah, so now I'm going to your problem. Okay, so Balin got an A value of negative 24.69, I'm going to say. B is,
609.9,
and C is,
negative 2,134. Gosh, 3.
how do you get out of like your little?
there's the right. Okay, so he got out these lovely values, so basically I can write this into my general equation. Right, so we have y equals negative 24.69x squared plus 609.9x minus 2,134.3. So this is my quadratic model that Desmos has generated for us. Right, so a little faster than us doing like the elimination method to find this, possibly. Okay, there was another value that they like found for us. They wrote r squared, which was
0.6.
965.
0.
yeah. So this tells you the strength of the model. So since it's really close to 1, then we know this model is actually a pretty good fit. And we could even just see that by how it was graphed anyways, that it was a pretty good fit for the model. So yeah.
Why is this different?
That's arbitrary.
Shut up, Amy.
Well, like you probably typed something wrong. You gotta be a straight line. You have to x squared. that section's done.
That's it.
Yep.
So we probably won't have a question like this on our test, right?
With this one.
I figured not. But are there some of the lessons that?
No, we're doing business.
Kind of. So you sure remember how to do this lesson because this is a project next week. So make sure you learn it. It'll make it easier.
We can use our notes for the project.
Yeah.
Just if we. And this lesson, it was writing quadratic equations, right?
Yes. Okay.
I believe it's December 7th already.
Isn't that great?
Nice.
Yeah.